Everyone, from wherever you're joining us, and welcome to our webinar, LoRaWAN for Satellite, a connected tour around the globe. So before we will start off with this topic today, and I'll start introducing the panelists, a couple of housekeeping notes for you. The platform you've dialed into gives you the opportunity to access multiple application tools that you can use at the bottom of your screen. In the resource list, you can download a copy of today's presentation and some additional materials that the panelists delivered to you. If you have questions for me or for our speakers, please use the Q&A tool to submit, and we'll provide you with an answer as soon as possible. On some PCs or systems, it can happen that the screen blocks for a moment, in which case just press F5 to refresh. Of course, the webinar is entirely recorded and will be made available on our platform in the next coming days. So before we introduce the panel to you today, let me give you a brief overview of LoRaWAN and IoT for satellite. So building collection and control systems in remote areas where no traditional connectivity plan and infrastructure exists is very limited. And for many years now, mobile network operators have been relying on satellite for backhaul in more remote and less developed areas of the globe. So we can think of deserts, islands, and mountains where terrestrial infrastructure was too expensive or simply infeasible. And without satellite as an option, it would have been logistically very challenging and rather expensive to connect these networks to the backbone. Satellite in these cases proves easier and safer to deploy and for people to use, and it has the huge advantage as to being totally indifferent to inhospitable grounds and other environmental restrictions. Another feature of satellite backhaul is the easy communication and support it gives to existing cellular and non-cellular technologies. So since early installations of satellite were expensive and offered only low bandwidths, satellite came to be viewed as the technology of last resort. But this fortunately has changed, and we're now taking advantage of a bigger range of satellite's capabilities. So even though satellite still is an excellent solution to cover remote areas, it certainly no longer is the only way or the only reason for which the market relies on these solutions. Several factors have now combined to make satellite backhaul an attractive proposition across the globe and in many different applications. For instance, there's an increasing need for high throughput data networks together with improved economics and advancements in technology in both the satellite capacity but also on the ground segment. So we see this as well when looking at new markets. Before, for instance, Asia and Africa were most popular destinations to develop satellite networks because of the many hard-to-reach areas, of course. But nowadays, satellite is no longer in demand mostly in emerging countries. We see equipped base stations are also to be found in urban areas. This is particularly true for first responder networks, for critical disaster response and recovery efforts, even when terrestrial networks have been damaged or are unavailable. So in a crisis, satellite will still be the main technology that can be counted on to provide consistent communications. And we all know that in a situation such as a global pandemic in which we live right now, crisis management has become increasingly important. Satellite will also, next to that, be fully interoperable actually with terrestrial networks, which makes for a good complementarity. So over the last decade or so, there has been a revolution in satellite technology, whereby the miniaturization of electronics has made it possible for businesses to provide new services using smaller and cheaper satellites. Low bandwidth IoT is a great example for such satellites, and many companies have started ventures to provide IoT services. The IoT, and in particular LoRaWAN technology, and that's of course the topic today, and our panelists are going to talk all about that, is able to capture data using a satellite network for a variety of challenging activities. We can think of marine engineering, earthquakes, and other large industrial operations. Which means that truly global IoT connectivity, something that only satellite can offer, will change these entire industries. So let's take a look at a couple of very commonly asked basic elements and questions for IoT for satellite that are often asked to our panelists to give you an idea of what we're looking for today in this panel. First of all, as you can see on this slide, the types of satellites commonly used for IoT applications are so-called CubeSats. These are very small satellites of up to 30 kilograms, and they circulate in a lower Earth orbit, which means less than 1,000 kilometers up. New IoT satellite players, such as the ones that will be speaking to you today, they have each typically launched between 3 and 10 of these satellites in low Earth orbits, with the expectancy to go up to 200 or 300 satellites in time. These CubeSats, they're managed very responsibly, meaning they have a very short life of about 3 to 8 years, after which they are automatically deorbited, which keeps space clean. Today, satellites have established 100% global coverage, so the entire world can be reached with these satellites. In comparison with terrestrial networks, satellite offers much of the same capabilities and device power consumption, so there's not much of a comparison there. And latency is measured in minutes or even hours, which means that there's no real-time data available, but this is actually hardly ever necessary either. So after this quick introduction and fact check, let me introduce to you our speakers of today, who are the real experts on LoRaWAN on satellite. We have Flavia Tara-Nardini, CEO and co-founder of FleetSpace. We have Rob Spurt, CEO of Lacuna Space. And we have Alexandre Tisserand, CEO of Keeney. They will explain you how LoRaWAN for satellite is a game changer for the satellite industry, with an expectancy of billions of devices connected in the next 5 years or so, and how this will lead to the equivalent of a new industrial and satellite communications revolution to connect everything on the planet. To do so, our speakers are going to talk to a variety of markets. So we have presented for you today markets such as utilities and metering, agriculture, supply chain, and the fishing industry. For each market, they will give very concrete examples of deployments and results in various parts of the world and with different customers. And this way, they're going to show you how and why satellite connections are either a complementary fit or a better fit to obtain a maximum of data value. So the speakers will all take a couple minutes to briefly introduce themselves and their companies. Flavia, let's kick off with you.
Hi, everyone, and thanks, Anne, for the beautiful introduction. My name is Flavia Tara-Nardini. I'm the co-founder and CEO of FleetSpace Technologies. Fleet is a company that myself and my co-founder, Matt Pearson, founded now 5.5 years ago. It's here in startup land, but it's been an amazing journey so far. For Fleet, the way we looked at the world was straight away understanding that LoRaWAN and low power wire network were about to change the world. So we wanted to find a way to leverage their capabilities for assets in remote areas. So Fleet is actually building small satellites, 6 units. So they are slightly bigger than the average in the market, but you can find actually bigger ones. The particular Fleet approached the low-band weather network systems on satellites in a different way. We work very much in what is called massive IoT market. So all the deployments that requires a lot of sensors. So what we have built is a gateway, very similar to what you all know in a simple LoRa gateway, but it's more complex and allows satellite backhaul, reducing throughput and create machine learning and pretty complex edge technologies. Fleet is deploying a constellation of 140 satellites in low Earth orbit. We launched 4 1.5 years ago and brought into use S-band frequency all around the world. And now we are launching 3, our next launch in a few weeks. We are getting to a point that we're going to mass produce satellites from July on. And the idea is really for us to gather all these massive IoT deployment. I will explain to you a little bit later, but what is important to understand about the FleetSpace network that is very much critical infrastructure focused. We are in a mission really to support critical infrastructure of the future, so energy, gas, hydro, water. and all those absolutely complex critical infrastructure where security is a big problem. So we very much focus on that. Last things I want to tell you, Fleet is building a pretty powerful technology in the satellites that is called beamforming that allows a very small satellite to actually gather a lot of data. And terabyte of data per year this is the massive IoT angle that we use, so allow a lot of sensors to be gathered in our network. So if massive IoT is important, is security important, it's what Fleet Space Network is all about. I'm going to pass my ball to Rob for his introduction about Lacuna.
Thanks. Excuse me. Thanks very much, Flavia. Thanks for the introduction there. So I'll tell you a little bit about Lacuna Space. We've kind of approached this in a slightly different manner to Fleet, and just to explain first about the orbits that satellites are in. They're in polar orbits, so they're about 500 kilometers high. And they orbit the Earth once every 100 minutes, and the Earth rotates underneath, and in that way you get to see the whole globe. And of course, that really is the attraction of satellite IoT. It is this possibility to cover the whole world and to extend the connectivity everywhere. But the thing that's sort of a little bit different about our approach was we've worked very hard to make sure we standardized everything. We standardized on LoRaWAN. We tried to make sure that everything we did was as seamlessly integratable with terrestrial systems. So we took the view from a user's point of view as saying, this is only going to get the mass scale adoption that's required if to users it is really, really simple. And to them, it looks like just a standard sort of LoRaWAN system. So we tried to make sure that we got the same nodes, the end devices, were working to the same battery power levels, and we're using the same frequency plans and connecting to gateways in exactly the same way. The only difference is that in our concept, that gateway is placed directly on the satellite. So for us, or for our users, hopefully, there's absolutely no difference. It's just a gateway that happens to be very high in the sky. The advantage of that being, of course, that it gets to see into places where other gateways can't reach. So to give you an idea of what the devices look like, here's a typical one, and that's it. That actually is a device with a temperature, pressure, humidity, accelerometer, usual suite of sensors in it, but also the connectivity to the satellite. So it goes from that, literally that device in the palm of your hand can be deployed straight out the box and connect directly to the satellite. What we're doing is, once again, all part of this concept of trying to put the control in the hands of the users, is say that you can buy those devices from us, you can buy them from multiple suppliers who are producing commercial off-the-shelf devices with our connectivity built in, or we can even give you the open source device design so that you can customize it, build in your own sensors, and it puts you completely in control. And the final point about this, this whole theme of trying to make it as simple as possible for the users or existing LoRaWAN users is we've got this device can also work in a relay mode where it can receive messages from a standard LoRa device on the ground and then receive them to this device and then relay it to the satellite. So I'll come on to some use cases a little bit later on, but the real benefit of this is you can have a standard LoRa device, say, deep in a building, and you can have one of these just outside with a clear view to sky, and it will transmit the message onto the satellite. So that's a brief introduction to Lacuna. I'll hand over to Alexander now.
Okay, thanks, Rob. So Keeney is a satellite operator and a global connectivity provider. As my colleagues, we are relying on the satellite network with very small satellites. The difference first is that we already have 8 operational satellites that are flying today with more than 20,000 devices connected. And we have rather different type of satellite, a little bigger. We are talking about 30 kilograms, 16 new satellites, which makes them very high powered. And this has 2 consequences that are very good for the users. The first one is that because of the big antenna and the high power, we have very, very good budget links with the device of the users. So it's again direct to satellite connectivity. And we also have, like you see on the scheme on the right, very large circles of visibility of the satellites. That means that with only 25 nanosatellites, we can cover the entire world. And that's what we will do, because in addition to the 8 we have today, we have raised 100 million euros of equity last year, which makes us totally funded to make the constellation operational within 2 years. So what we have also now is the product line to test and to deploy the connectivity, because we know integration and development of devices is sometimes takes time. We have made things easier for integrators. So we have developed small chipsets like this one you can see on the slide. They are 7 millimeter wide, and they're jointly managing the radio frequency signals. You can also have the size just a little above with the modules integrating the chipset. Very easy to connect, and of course we have all the dev kits and open source design that you need. We also have off-the-shelf devices. Also, we are more in the idea of developing an ecosystem of manufacturers, but still we can have some off-the-shelf devices to connect to the Keeney's network. So also about the use cases, we will see just a little after, and I will pass the slide to the others to present the use cases.
Thank you
so much, Alex. You're gone.
I just wanted to thank you for your introduction and let you know that we're moving over to use cases that have to do with utilities, metering, and larger industries. So Flavia, you have a couple of very interesting use cases in this domain, and I'll let you present those.
So let's go. What I find very interesting about what we are doing. I mean, clearly space is fantastic, and all these constellations are creating an opportunity that is going to really change our IoTs in the coming years. But what I find very interesting is, at least in my 6 years running this company, is witnessing the type of application and use cases that we've been able to leverage and their impact on the world in general. So I really like the fact that we are, all of us, and I'm going to tell you a little bit more about the heavy industry side, but all the application from agriculture to industry to maritime, these are applications that were not possible before. So this is the magic of what we are building here. So in the past 5.5 years, we have the journey that we have done in industrial IoT. In the first couple of years was very much try to understand where the position of the market, where the market was. Again, as I said before, Fleet was very much built for massive IoT, so a lot of sensors. They required some analytics and machine learning in the field, so a lot of data. So it's not little bits of data, it's a lot of data, pretty heavy industries, heavy remote management. So we started looking at the heavy industry. And of course, when you look at all the critical infrastructure, the exercise becomes pretty complicated, but also very challenging. So we are talking about companies managing gas, water, and energy in a really extensive way. So all these assets that they manage are pretty much remote. There are some metro assets, but very much remote. So we started looking at this industry and see how we can leverage small satellites to support them. So I'm going to present you some cases that have been the most successful in the past couple of years, and we've got a lot of customers leveraging them. But I want to highlight two concepts that for me are very, very important regarding a satellite solution for heavy industrial IoT. First is that critical infrastructure manage critical data. We're really talking about data that cannot be whatsoever reached by third parties, because in most of countries in the world are critical data. The second is, pipelines and power and lines and utilities and water. It is important. Cybersecurity is very important in this type of solution. The second point that I want to make is that the management of these remote assets currently is done by this industry with a lot of complicated manpower involvement, and safety implications are really high. Let me walk you through the example. So the first one is our effort in the gas industry. Of course, pipelines are just extensively massive. So as you can recall, we are based in Australia, and I think Australia and IoT is absolutely exploding, and we have the same customers facing the same issues in Canada and US. So long pipes. And most of the time, the terrestrial infrastructure are pretty not present or patchy. So we thought, would it be possible to actually create a monitoring system in the entire pipeline? They usually go underground in order to make sure that actually we leverage on-time monitoring. So we created what is called a smart post, and a smart post allow to identify diggers with a machine learning camera or LoRa enabled. So it's fantastic. As you probably all know, LoRaWAN and big data and cameras is not an easy marriage. But what was fantastic to achieve is that all this camera run machine learnings and send out to satellites to send alarms of where the digger is. Diggers are the cause of gas leakages, environmental disasters, and death all around the world. And there are so much money that are spent on managing these pipelines, the people in the car up and downs. It's really hard to use drones because they're so expensive. It goes inside deserts. It's a very complicated maintenance requirement. So literally, you kind of periodic human-based patrols. So there are many other things that you can do when you've got a massive IoT network. So they deploy this LoRa network all around the line. They put these smart cameras, and they put a lot of many other sensors in the pipeline, almost substitute all the periodical checks. So we have demonstrated saving in a big pipeline of millions. And the safety actually is an important factor that cannot be underestimated. Another important application that I want to talk about is hydro. Hydro, and I'm a big fan of hydro. It's probably one of my best use cases. It started the fleet by working with the biggest hydroelectric company in Australia and then moving to Canada. Hydro companies manage so much water and very remote situation, location, mountains, and it's pretty hardcore. I've been there. I've been traveling 3.5 hours, staying there for 8-9 hours, and having people with pen and paper checking pipes and leakages and movement of pipes of water. It's actually quite amazing that you can reduce your road time by 80%, but the amount of water that you can save by deploying incredible LoRa-enabled valves and seismic and soil moisture sensors. We have started working with ABB on this project and allow them to move into LoRa. This is a large scale. And what I love, and I have to say that this is the most complicated environment I've ever deployed, with trees and hills, and LoRa just behaved in a really fantastic way. Another interesting use cases for us that is very, very strong is ports and wires. And so you got a high voltage asset monitoring and the low voltage asset monitoring. Again, in US, Canada, and every country in the world, these are critical infrastructure. Data is really important. Ports and wires are historically really unconnected, because you have to bear in mind that the numbers are really big. We are talking about companies that can handle 1.5 million ports and 750,000 transformers. The high voltage asset monitoring is interesting for me to talk about because they have fibers. So in the beginning of my journey, I almost thought, because they got fibers and the asset is actually quite complicated, connected, that will never require IoT or satellites, no LoRa. But my assumption was absolutely wrong. Fleet is working with maybe 50 or 100 transmission companies around the world, allowing them to do wireless LoRa-based monitoring that would not be able to happen with SCAD and fiber. And also some application underground. By having a gateway and gathering all this data, we are able to gather data for underground cables. It's actually really amazing. So you have substations that are very, very connected, and then you have all these lines, and finally you can connect them with all these LoRa satellites and ensure that the security is high. The topic on low voltage monitoring to a distribution network is even more complicated, because these assets are way more expensive, but I was super impressed by the fact that the way energy operates nowadays, and bear in mind there is a change in the networks, decentralization of data that is actually quite fascinating to watch. They operate without visibility. They are looking at infrastructure around the world that are struggling by the change in energy operations, more solar panels, more solar farms. You got this highway in the middle, it's completely unconnected. So how you can activate yourself to reduce outages, in remote areas, but almost everywhere, knowing when a fault is, knowing if there is a reverse flow that is happening in the network. Again, the fact that we were in Australia was really good for the first 3 years of our work. Our customers have got 70% of the networks unconnected. Satellites is the only issue for them. But we have demonstrated that you can actually increase 25%.
It seems that Flavia is having some connectivity issues. We might be coming back to her a little later. Thank you, Flavia, for the very interesting use cases. Rob, actually, Rob Spurd, Lacuna Space has some use cases in the same market segment as well. Would you like to take over and present?
Yeah, certainly. So, we've also seen a surprising amount of demand from utility companies. It wasn't one of the areas that we anticipated being as big as it's really turned out to be. Everybody's kind of familiar with the huge rollout that's happened with sort of smart meters in towns and cities, but you don't need to go very far away from cities where you kind of run out of connectivity. So there are lots of people there and lots of areas where turning around and saying, well, the smart meters is all well and good and very clever trying to optimize the use, but I'm still living in a completely different world here. I'm still dependent upon people coming around and reading meters. And of course, for the utility companies, that's a huge cost and it's a huge inefficiency. So actually being able to deploy very simple devices like the ones you've seen in my earlier picture there that can measure and meter electricity, water, sort of supplies into houses in remote areas is kind of really a really very interesting application for us. For me, it also goes a bit further than this. Firstly, there are many places that aren't even so remote where people have also implemented our solution. Just because it's so simple to deploy, you don't kind of need to worry about connectivity to an internet or indeed power It's just battery powered. You can just drop these devices on. So although we see strong demand in remote areas, we also see a lot of people picking up on this just simply because it's simple and it's easy. And I guess the one use case that I really enjoy and like talking about is this one, because it's a completely that's pictured on the slide here, because it's a completely new sort of utility area that's being enabled by LoRaWAN. In this case, this is solar cells and solar farms supplying electricity into remote villages, and the issue there is trying to meter the amount of electricity that's being used by each of the houses or each of the facilities in the village. And we're working, the one particular example I'm going to give here is a project we're working on with a company in Colombia, and where they're installing banks of solar arrays into small villages that haven't previously been supplied, and then they're incorporating these very simple devices that we've got in order to do the metering of the supply and monitor the sort of health status of the equipment. So that's one set of examples around sort of utilities and utility monitoring. Coming back to this sort of theme of the industrial sort of applications, of course, a lot of our sort of natural resources, by definition, are in remote places, in places which are difficult to connect. So you can sort of think of oil wellheads is one good example. You get lots of sort of wellheads across different places. Excuse me, that's lots of wellheads in different places, and those are sort of single wells, and what the oil companies want is just very simple deployment. Basically, just put a single device to monitor what's happening, give them health status, give them to tell them exactly what that the equipment is still working, so that they can then schedule maintenance for those pieces for those facilities. And another example is sort of larger mining areas. Once again, mines and mining tends to be in remote areas. It's where the natural resources are naturally not connected on the grid. So in those cases, actually having ways of connecting within that environment is very useful. I think I'm going to hand over now to Alexander.
Okay, thank you, Rob. Yeah, I wanted to talk to you about use cases that is already deployed in some countries like South America, Spain, or other ones in the world. At Keeney, we have been tracking wild animals for years, even decades, but it was more for science, to give the scientific community a study of migration and how the animals were doing their day. But it came to us the necessity to track herds. We have billions of animal heads that are raised by humans, of course, and we have been questioned by local governments on how can we track animals. Well, maybe not all the animals, because it's not always needed, at least to prevent some epidemics by detecting what is their behavior, what are they doing, are they having strange behaviors, and so by placing some sensors on it, you can detect such behaviors. And obviously, it makes sense for satellites only in areas where you have open fields, when you have lots of heads that are going away. You don't even really know where they are. And so the really important point here is to have direct connectivity to satellites, because we are precisely in open fields, and so you cannot be sure that a single gateway would be reliable. When you are on a farm where it's all closed, you can do with the gateway, but otherwise you will need some direct satellite connectivity, which is what we are doing. And so the really important thing here is to have the good device with the really good price point, so that you are able to deploy a high number of tags with acceptable price for farmers. And then with that, you can partner with added value providers. We are not doing that today, to have some services analyzing the data and detecting epidemics and raising alerts when needed, for example. So we are tracking herds, but also more generally in agriculture, we can have also sensors that are detecting, that are monitoring soils for humidity, for how much of food you have at a specific point. So this is really a really growing area of business, and satellites is definitely a really good business value in that. Rob, I give it to you back.
Yeah, so I've got a couple of examples of sort of smart agriculture as well that I'd like to talk about. I mean, firstly, I must say, as somebody not coming from this background, I was just, more learned about these applications. It was really quite astounding how scientific agriculture has become. And purely down to my ignorance about the particular industry, but it really is a hugely scientific endeavor to try and optimize the sort of yield from crops whilst you're minimizing the use of expensive and environmentally damaging fertilizers. So to try and make sure that we can get the most out of farms. And of course, all of that depends upon data. And many farms have now become instrumented with LoRa and with LoRaWAN. There's many sensors out in the fields doing things like soil moisture or whatever. But farms being farms, they tend to be pretty difficult to get completely connected because they'll often have valleys or trees or obstructions. So being able to extend those networks to include on soil moisture sensors is one particular example we're working with a company that's manufacturing soil moisture sensors, and being able to just drop those in, and they've got the connectivity built into them, being able to put them in. It's dead simple to deploy. It just appears as a normal LoRa network, and then the data that we collect is routed directly back from those sensors to whichever IoT platform the user is actually already familiar with. We're not trying to control the data in any way or add any value ourselves. We appreciate that there are many, many applications out there, many people who know so much more about this than we could ever begin to know, as specialists in the field. So our task and our challenge is just to make sure that we fill that gap, that we can enable the data to get from the remote and difficult access places to access straight into the hands of the farmer or into their analysis package, so that they can actually make good use of it. I think one other example that I got, this is sort of very similar to the animal tracking, but we've got we often like to talk about some of the good use cases we're doing with endangered species in Africa, and we're doing some other sort of animal tracking in people possibly seen the use cases. We've spoken about penguins in the Antarctic, and also animal trapping exercises that we've got going in New Zealand. These things are all we're presented very much from the sort of protecting the endangered species, but of course to the people that kind of live and work in those areas, to them very much it's also about how do they live in harmony with these species, how do they make sure that their sort of crops that they're growing for their own villages and for their own use are protected. So knowing where the animals are, being able to control that to make sure that they can live harmoniously with those animals is a very important thing to local people. And of course, in many of these areas, you know, you're talking about wildlife in vast areas where there's just no other feasible connectivity option. So having a simple device in this particular use case on a collar on an elephant is great, and it enables them to track and understand what's happening. Now, of course, we present this case because it's very attractive, but really the extension and the commercial case is any large-scale sort of animals, so any domestic farming. We're working with farmers who've got ranches where they're covering huge areas, where they're sort of semi-wild herds of cattle in South America, and also in Australia as well. Farms that cover vast areas. And exactly as Alexander has suggested, we've got the technology where we can put a sensor that's small enough, battery powered to last for years, that can connect from directly from the animal to the satellite. So it's just a really, really simple system. So I think handing back to you now, Alexander.
Yeah, great, thanks. So yeah, now switching from agriculture to logistics. Business case in logistics are not new, and we've all been, even in non-satellite world, and especially in non-satellite world, trying to track whatever can be tracked on trucks, on boats, containers, or whatever. And it's still a challenge. Satellite is bringing lots of easiness to help meet the business case. But what I would like to talk about is a specific one with Keeney's connectivity being hybridized with LoRaWAN connectivity. So we have a device deployed that is doing connectivity both on satellite networks with Keeney and also with terrestrial networks on LoRaWAN. The point is we have here devices that can switch from one network to the others seamlessly for the users, and so benefiting from the right network at the right time. Also, we can have this seamless integration because we are talking about quite big industrial companies that are tracking assets from their production or assembly sites to point of sales, for example. And so on these production or assembly sites, they have private LoRa networks. And so the problem for them was to lose connectivity from one side to the other. And so thanks to the device, they can connect at their site as they were doing before, and they can connect to satellites without even seeing it. So this is rather interesting because then you are putting away the roaming issue in that case, which is quite usually painful. So it obviously doesn't help for roaming on public networks throughout the world. Still, at least not now, because we don't have the right all-in-one LoRa chipset. But still, for these use cases and for these big companies, this is very interesting because they have the all-in-one device that fits for their need on tracking logistics. I think Rob, you also have one example about this.
Yeah, certainly. I mean, I'll just echo what you've said there, really, Alexander, that, you know, roaming is possible. There are tracking devices that exist out there, but it really is very complicated. You need agreements in so many different places with so many different suppliers in order to do it. And of course, it's expensive. So roaming off cellular stuff, assuming there is a cellular connection, which is not on many parts of sort of transcontinental journeys of goods and equipment, it's complicated. And of course, the other factor is that if you're relying upon sort of satellite navigation systems like GPS or Galileo, then it's very power intensive on the device. So actually you end up with a tracker device that can perhaps track, say, a shipping container for a single journey. But what we're really interested in, what we're seeing huge growth in at the moment, is the interest of companies from companies that can put trackers directly on the side of, say, a cargo container or some transport pallet or something like that. And they can leave it there for years and track it, literally years off a single charge. There's no maintenance. There's no complex roaming agreements to be done. It's just simply a fact of putting that device in place, and it basically we advertise it as fit and forget, and that's exactly what it is. We've seen some other couple of other suppliers who are really doing some quite elaborate things with these tracking devices. It's getting more and more fancy in that they're actually taking a lot of the recent advances in machine learning algorithms and machine learning chips, pushing that to the edge, building it into the device. So we've got one particular company that's building in basically a shock detector, but rather than continuously sending messages back, measuring whether the piece of equipment has experienced or felt shock or been dropped or whatever, it push all the smart computation into the device, does that in a low power manner, and only communicates back if there has been some event. It basically learns, okay, has this container been dropped, or was it just the nudge or the shock from unloading it, or has it undergone some sort of serious damage that I need to report? So, yeah, logistics for us is a huge area, and you know, I think a huge area for IoT in general. Okay, so I think I'm handing back to you again, Alexander.
Yes, thank you. Oops, previous one. Yes, back to food and kind of agriculture. We're talking about fisheries here. Fishing vessels have been tracked for years and decades, and today big industrial fishing vessels have their own satellite connectivity, which big modems that are very power hungry, but because you have power on board, there is no issue with that. Sometimes the data plans are expensive, but they have huge needs. So we're not talking about this here. We're talking about the numbers of what we call artisanal fisheries or small-scale fisheries. Small-scale fishing is what you can see on the picture. There are small boats, some like 10 to 15 meters long, that are going at sea for like 7 to 10 to 15 days even, and with on board nothing but just an engine to push the boat. But besides that, they have nothing, just enough to capture the fish and to make cooking on board. And so obviously no power source to feed any power-hungry device. And today, this small-scale fishing, like in West Africa, in Southeast Asia, represents 50% of world fish catches. So that's totally huge. And in number of vessels, we're talking about 80% of world's fishing vessels. So this is going well for local population, except that they face two issues. First one is that because they are still growing, there is a risk on the halieutic resources to be too much fished, too much catched, and so they have government have to track a little bit these embarkation to ensure they are not fishing in illegal zones. And secondly, they still have a lot of accidents with these embarkations, which are quite small, and because there is no communication system on board, they sometimes are catched by storms or things like that. And so what we have developed with partners is this kind of device you can see on the slide that can be very resistant and reliable, very autonomous, that can be sealed on these boats. And this is coupled with mobile applications so that local authorities can connect to the device to enforce immatriculation and to see what fishing zones that they have been gone to. One important point here is besides the device itself, the functionalities, the reliability, the price point, is the acceptability by the fishermen themselves. And this is where we have put, in accordance with them, functionalities of track and rescue, so that you can see the red button here, that they can push on the button and this sends a signal of distress. And so local authorities can send rescue boats to help them. Also, because the system is bidirectional, we can send to the device some information like storm ongoing or things like that. I didn't mention it, but it's like the other one for logistics. This one is hybridized, meaning that when you are close enough to the coast, you can use terrestrial networks if available, and otherwise you use Keeney's networks for that. And finally, I wanted to finish with use cases for consumer people. All what we have seen today is more on the B2B side, and it's also primary markets at Keeney's. But we also have this B2C device, connected beacon, which is designed to help hikers and outdoor people when you go in far remote mountains for several days and your cellular network is not available, or you don't have any more batteries on your smartphones. You have this beacon. Today you can already buy some beacon that are doing some search and rescue function. It's like a beacon you buy, but you don't want to use it in any way, because if you use it, it just means that you want to be rescued and you have an issue. And so we felt like it could be better to have a device that you want to use anyway, even if you have a rescue function. And so we designed with another partner a beacon device that combines this search and rescue function. And so the search and rescue is a satellite international system that is connected to local authorities in each country that is partnering with these satellite networks, which are about like 60 or 70 countries. And so the device allows you to first be tracked, to have all tracking on your smartphone if you need. You can send some like small short messages by satellites with the beacon, and you can also have this button to send rescue alerts to these satellite networks. So this is very interesting. There is a good market for that. Today is not hybridized with LoRaWAN network. It's pure satellites, but definitely it can benefit on a version 2, for example, from both the local LoRaWAN networks when in range, and satellite networks when not in range of terrestrial networks. So this is something we are thinking about. It will depend on the usability of it and the interest to connect to local networks. I'm done with that, and so I'm giving back the floor to you, Anne.
Yes, thank you so much, and thanks, Flavia, Rob, and Alexander, for these brilliant use cases. A lot of information. Let's quickly wrap up our presentations with a couple of conclusions, future developments, perhaps the market expectations for the satellite market for IoT and LoRaWAN. So Flavia, did you want to perhaps take some time to wrap up your use case since you dropped off for a bit and give us some insight into future market developments?
Yeah, we got unconnected during a presentation about connectivity. It's great. So listen, it was quite clear that where the market I see focusing that is very interesting is all these critical infrastructure areas. Just fascinated by all these operators that are starting to use, for the first time in history, satellites and LoRaWAN in large scale. For me, that is the industrial revolution that we are going through and the support that we are going to the industrial revolution. Regarding fleet, we are going to launch a satellite in a couple of weeks, and another one will follow, and a third one will follow in the coming months. And then we are building mass manufacturing of the satellites because we are ready to scale with demand. We are present heavily in Australia, New Zealand, APAC region, Canada, and US. So it is going to be a lot of work because in the past couple of years, the explosion from an energy sector and critical infrastructure has been amazing. And the reaction to the product and the satellite IoT opportunity has been great. But one thing that I want to tell that could be interesting for everyone that's listening to the story, Fleet has got a lot of interesting work in the mining sector, particularly related to exploration, that I haven't presented today because this is a long conversation. But we have worked on it in the past couple of years so profoundly that we have created now a mission called the Seven Sisters that is bidding for a moon mission to bring LoRaWAN on the moon. So we want to do a big deployment of LoRaWAN-enabled sensors for understanding the subsurface on the moon. And we have a big consortium that includes most of the mining and robotic company in Australia and APAC, and the world as well. So it is, I look forward to telling you how LoRa is behaving on the moon as well. That is going to be an interesting exercise in the next couple of years. So this is what the future holds for us. Rob, on Lacuna?
It's just absolutely amazing to listen to things like that. I mean, during my lifetime, we've just seen this complete revolution in satellites where it's gone from essentially satellites being an endeavor of governments to then satellites being an endeavor of large private companies through to the possibility that innovative companies like ours can now actually do it. And deploying satellites has become, pretty commonplace. We've got more being launched in another couple of weeks. It's that is just become a routine thing. But the interesting thing is sort of like, well, what possibilities does that give people? And it's not just about the low cost and reaching into those areas so that we can do things that we already do, but do them much more efficiently and in different places. It's about those use cases that we just completely enabled that just were not possible before, that suddenly have become possible now. So I'm just really excited to see what use cases come forward, because it seems to us that every single day we're coming across something new that we hadn't thought or imagined or envisaged that people are able to do with this IoT connectivity. I just think it's an incredible time to be alive. It's sort of, it's taken us probably a couple of decades to get all of people connected to the internet, and we've done a patchy job of that. In a lot of places it's been done well, in many places it's been done really poorly, but the speed with which we're kind of deploying and rolling out IoT so that we can connect things to the internet is really quite impressive. And hopefully through the endeavors of companies like ours, we won't find that there are whole areas and places and people that are left behind in this revolution. Alexander.
Right. Yeah. Yes. You've said it all already. Well, there is so many interesting things to do now because satellite is no longer complicated or expensive as this has been. Seeing you guys that you are building new companies with the aim of hundreds of satellites, that things that would have not been possible like 10 years ago. It's quite amazing. And we're talking about satellites, we're talking about also innovation on the device. And like you say, Rob, there is, and Flavia, there is a explosion of new use cases. Well, we have talked about some today, but I could have mentioned like connected hives to connected cap of launchers of rockets. It's just you couldn't imagine to connect rockets with this kind of sensors. This is so funny and interesting. And as for the expansion, we are so launching our new satellites in 2023, and then this is the first generation. Then we are already thinking about the next one, because we are all trying to do things on the existing frequency plans and existing technologies. But I'm quite convinced that things will also evolve in the coming years. We'll have new frequency ranges to use. We will have new technologies to integrate, and so IoT with space is just at the beginning, and there's still a lot to do in the coming years.
For this interesting wrap up, and a lot of projects and new features to look out for, I can hear. So I want to wrap up our webinar today by thanking our Destination LoRaWAN sponsors who helped make these webcasts possible. So thank you to Machine Q, a Comcast company, as our Destination LoRaWAN Gold sponsor, and to our 2 silver sponsors, Birds and Charter Communications. A moment to thank, of course, all of our LoRa Alliance members who participated to the webinar today. Please take a look at the amazing benefits that are available to LoRa Alliance members by viewing the membership benefits document. You can find it in the resources section of this tool. The LoRa Alliance drives the future of LoRaWAN, and we want all of you to help shape that future. So take a moment to see how you can join us and our ecosystem. So through the Destination LoRaWAN webinars, we will be bringing every week new content. So please visit the Destination LoRaWAN Engagement Hub and sign up for notifications for upcoming webinars. If you or a colleague, you would like to view this webcast again, an on-demand version will be available in approximately 24 hours, and it can be accessed using the same audience link that you used to attend today's webinar. So thank you again very much for your attention, and we're looking forward to getting in touch with you. Have a good day.